My name is David Riddle. This video is about one of the many adhesives that I use in my work as an inventor, designer, and manufacturer of custom tools for professionals working in the fields of mechanics, electronics, and optics. Today I'm going to demonstrate and talk about two types of JB Weld, commonly known as two-part epoxy glues. But before we get into the details, both John and I would like to thank our more than 16,000 subscribers to our channel with only 8 videos that in less than a year have accumulated over 916,000 views and with more than 2,000 comments that I personally responded to. I would also like to say that this video is not sponsored in any way by JB Weld. I purchased the product at retail or online just like you do. If this video was helpful to you and you wish to purchase some of the JB Weld products, go to the description area and click on the More word where you will find links to Amazon to purchase all of the materials used in this video. If you purchase through these links, John and I make a tiny percentage of money that helps make these videos possible. The reason I've changed into nitrile gloves is because I'm going to be using solvents, and solvents don't attack nitrile gloves, and in this case we're using acetone to clean the surfaces. But we're going to be focusing on these two glues, both the JB Weld and the JB-Kwik. And the JB-Kwik is a 5-minute epoxy, and the JB Weld is a minimum of 24-hour epoxy. Now, there's other epoxies available. As you can see, Loctite, Gorilla, and JB Weld on these bi-tube type dispensers that automatically produce the same amount of mixture, but I've never used these because of the fact that I prefer JB Weld. Now, the unique thing about JB Weld is the fact that it is magnetic. It actually has steel in it. So what I'm going to do now is show you, I have both JB Weld and JB-Kwik. It sticks to a neodymium magnet, just like that. That means that the epoxy includes steel. It doesn't say it on the materials list for the safety materials list, but it does indeed have steel in it. Now what I'm going to do is, I'm not going to demonstrate Kwik because I have another example of Kwik. I want to really use this JB Weld, and I'm going to open the package, and this is a fresh set of tubes, and I'm going to throw these in the trash. And this is the tubes, and in each package it has a cap that pierces the sealed top just like that. Seals it, pierces it, and seals it. It's a really unique feature that other glues have, but this allows you to do that. And anyway, the point is, what I'm going to talk about now is what surface to mix this on. And the reason is, why is it important to the surface? If you use cardboard or paper or some other thing, it's going to have it'll absorb some of the materials. So what I'm going to do now is I'm going to clean this surface with...
What is that surface?
This surface is polyethylene. Actually, it was a Bondo spreader that I have in my collection, because I also use Bondo and other materials.
So it's plastic.
It's a polyethylene plastic. So the first thing I'm going to do is very carefully lay out a specific amount of material.
So the plastic is just for mixing. It's not.
The plastic is just for mixing, okay. And the reason you use plastic is that it does not absorb the chemistry that's in the glue. If you use paper or cardboard or other absorbent material, it will indeed have...
What other surfaces can you use other than plastic would be okay to use?
Plastic, glass, anything.
Steel?
Yes, anything you want. But what I use is this because eventually what happens is that you can crack it after it's cured and pop it off of this material because nothing really sticks to this. So I use the end of the broken off Q-tip, and I use Q-tip brand. I use Q-tip brand specifically because they have this stiff cardboard thing that breaks easily. But then I mix these two together, and I'm watching the color, and I'm making sure that all of the material is mixed properly.
Obviously, the two colors are made that way so you know when you're mixed, fully mixed.
Yes, that's one of the reasons,
What's the other reason?
is because of the fact that they're completely different materials. One has steel in it, and the other one doesn't have steel in it. But that isn't the reason. There's clear epoxy, and you can't necessarily see that mixing, but it just makes it easier for this. Now, the other thing that I do, okay, is to make it thoroughly mixed. Now, this is the 24-hour material, okay, and the reason I'm using this material on this next step, which is to apply. This is plenty mixed right now. The reason I'm including an ohm meter in this demonstration is to differentiate the difference between a conductive piece of metal and an anodized aluminum piece of metal. Now, anodizing only applies to aluminum, but specifically, anodizing is the process of coating the surface with aluminum oxide. It turns out that aluminum oxide is an insulator, so we need to make sure that, is it anodized? There's aluminum, but there it's not conductive. It's an insulator. And so we have to remove that insulation so that we can get down to the metal to really bond, because otherwise the bond is not nearly as strong. Now, what I'm going to do is sand this
So when you're dealing with aluminum, is that something you
See,
want
but
to
you can
check?
see the difference in this, the silver and versus the anodizing.
Wait, show me that again. Show me that shot again.
Yes.
Hold on. Yeah, I can see it. Don't move. Okay, go ahead. Go ahead. You can start sanding.
And I'm going to remove that anodizing. And the reason I'm removing the anodizing is to make sure that that surface is absolutely free of the anodizing, because I want a tooth to be formed, and I'm forming this tooth with 60 grit sandpaper and making sure that none of the anodizing is left on there. And I will check that with, I can see it very clearly that it's no longer there. As you can see.
But you're going to check it with the ohm meter. Yeah.
No, I'm not going to check it. I can see very clearly that it's removed. And now what I'm going to do is I'm going to bond this bracket to this bracket, and I'm going to do the same thing. I'm going to form a 60-tooth grit so that it really has these micro fissures that produce a very great adhesion in the material. But this applies to any material you're going to bond. You need to form a tooth, and secondarily, you need to very carefully clean this with a fresh paper towel and acetone to make sure that there is nothing, no oils, no grease. Cleanliness is critical for proper bonding of epoxies. Now, one of the techniques that I'm going to use here is a technique I developed originally for heat sinking, where I use a plastic disposable knife, and I use it as a scratch trowel, like a mason uses or a scratch stucco uses, to produce an equal amount of glue across the entire surface. So I basically pick up some glue, and then
almost like a troweling for a tile.
yes, exactly the same thing. And then I do the same thing.
Do you worry about the plastic contaminating?
No, the plastic
bond?
will not contaminate it. It's passive. So now I do the same thing.
Okay.
And in fact, you can go the other way. Go here and here. And now I want some in the hole, and I'll show you why. Now I'm going to take this, I'm going to place this just like this, and I'm going to press lightly. And then I'm going to heat it with a heat gun to make sure that this material is very carefully and flows into, and the epoxy flows directly into the surfaces, the micro fissure and surfaces that are on the epoxy and on the metal, and it flows together to form this very strongest bond.
Dave, what about clamping in this situation? Would you want to clamp it? Or
Generally,
do you not
I
need to?
don't clamp because of the fact we don't want it, all the epoxy to disappear.
Okay.
Okay.
That would press the epoxy to come out.
Yes, and then I push down on this
'Cause
and
that's
move it
still
around.
Slippery.
Yeah, because I've.
So you want to keep that cake of the bond in that.
And that hole, that acts as a rivet when it flows through that hole. So you can drill multiple holes and do that. And what I'm going to do now is I'm going to clean up. I'm going to clean this up using solvent. Remember, this is.
Now, what if solvent gets into the glued area? You want to
No
avoid
solvent will get into the glue area. That's not the issue.
that. Okay.
All I'm trying to do is clean this up a little to produce a more cosmetic and more pleasing bond.
Could you sand off that bond later if you needed to?
Yes, you absolutely can.
You just don't want to.
Yes. But now this needs to cure for quite some time. Okay?
Put it down on the thing.
It needs to cure for quite some time. But that will be an extremely powerful bond based on the fact that I've heated it to flow the glue into the micro fissures and the sanding tooth that I've produced on that.
So Dave, how do you choose when to use JB Weld? And explain maybe with this part that you just did, why are you using JB Weld in this situation? And when does Dave Riddle make the choice, oh, I'm not going to weld this, I'm not going to solder this, I'm going to use JB Weld?
Well, obviously in this demonstration, I just wanted to show the methodology used by using a plastic fork to act as a scratch trowel. But I mean, this could easily be threaded, riveted, bonded in a myriad of different ways, spot welding, everything possible ways. But I was just using this as a demonstration. Generally, though, when you want to do something that doesn't require a heat or drilling or tapping or any aspect of it, that's why you use JB Weld, because of this particular glue is extremely strong as compared to all the other epoxies. Its inclusion of steel powder makes it a much stronger adhesive than regular epoxies do.
That makes sense, because I remember when you fixed one of our cinema tools that we use in our other business, that you used the JB Weld because you couldn't solder it, you couldn't drill it, you couldn't screw it. So it was kind of like there was only one
methodology to be used, right?
Right.
And in fact, what I'm going to do and show now is I'm going to show actually the use of bonding glass.
Well, before you do, one last question is how strong will that bond be that you just did?
It's extremely strong. It would be very, very unlikely
you couldn't
that
pull
it
it apart
fail.
with your hands.
Well, after it's cured, absolutely you could not pull it apart with your hands.
Okay.
No, it would require.
What if you took a sledgehammer to it?
Well, that might do it, but
Right.
basically what happens is that this metal is going to peel eventually, and so it's in tensile instead of shear. If you try to just shear this off, meaning that you attach this on a vise and then pull this very linearly along this, it would be very, very strong and shear. But if you bend it and peel it, it's going to be much more fragile.
So, Dave, as I know there's other epoxies out on the market, explain why you use JB Weld as opposed to other types of epoxy.
Well, I found that JB Weld, especially the 24-hour material, is extremely strong, much stronger than any other epoxy I've ever utilized in my work. And the reason very likely is because of the dissolved metal particles that are inside of that epoxy, which forms a much stronger matrix of adhesion to the surface, not only in shear but also in tensile. It's very, very powerful material. I mean, obviously, like I said before, you can have all kinds of different attachment mechanisms, but sometimes you need something that's chemically inert. You mean, if you have something that's a metal and then you want to be able to, say, a piece of glass attached to a piece of metal, and then you want to make it waterproof, there's really no other means to attach it and make it totally waterproof other than possibly O-rings and clamping materials, whereas simply a bead of JB Weld around the glass and around the aluminum makes a watertight seal. And it's also resistant to chemicals, both solvents of many types and corrosive materials, all kinds of things. It's very, very immune to those materials. I talked earlier about bonding glass to glass and glass to other materials, and I also talked about forming a tooth. And it's possible to form a tooth on glass using an orbital sander. And what I'm going to do now is I'm going to take 2 microscope slides, okay, and I'm going to scratch up the surface using an orbital sander. And right now I'm going to grab this sander and I'm going to sand. And you'll see when on the close-up, you'll see that I've formed a tooth. The reason that the aluminum oxide sandpaper is harder than glass, and it shows a great tooth on the glass surface, like a frosted glass. But what I'm going to do now is I'm going to clean that, because I don't know whether or not the material that I just sanded with is completely oil-free. And what we want to do is we want to clean those surfaces. Okay? And then I'm going to take and put some glue on this material. Yeah. And then I'm going to use the same technique of spreading the glue with my scratch fork, or knife rather, on both surfaces.
So again, you're troweling it with the knife.
With this, yes.
Okay.
And then I simply wiggle this together, set it down, press down.
But not too hard.
Just the right amount.
You don't want to push it out.
And then, again, the heat gun.
Do you always use the heat gun in most situations?
I always use the heat gun for because it absolutely it makes the bond much more tenacious by flowing into those microstructures. Like I said earlier, it's as simple as that. And when after you heat it like this.
Does JB Weld say to heat it up, or is that something you've discovered?
No.
Okay.
That's
part of the instructions.
No, they're not part of the instructions per se. But also, you can also heat up the glue before it cures, like this, okay? And you get it softer again. So if you want it to flow, like watch what happens now. It's much thinner in its material because of the fact that the viscosity has been lowered, has been lowered because of the fact that it's thinner because of the heat. It's as simple as that. Now this bond is much stronger than the glass and will definitely bond glass to glass. If you first pre-etch it, and etching using aluminum oxide 60 grit paper on the glass itself, that makes the bond adhere much, much better.
So, Dave, in closing, can you tell our viewers about maybe some of the other ways you've used JB Weld in some of your other projects?
Well, I was asked by a fuel injector rebuilding company to make a specialized sensor to determine exactly the milliseconds of the closure of the opening time of the fuel injector to match fuel injectors. And what I did is I ended up taking a cigarette lighter that had one of those click type piezo igniters in it, took the lighter apart, but I needed to have some way to attach that piezo attached to a magnet so that I could hook it and stick it onto the side of the fuel injector. And then I hooked up wires and a piece of coax, and I embedded all of that inside of a brass tube filled with JB-Weld, and that acted as a strain relief for the coax cable out to the oscilloscope, and also held the magnet securely, but it also allowed that action of the opening of the fuel injector to be connected to the piezo generator. And then I used a dual channel oscilloscope, and we were able to determine precisely within microseconds how long it took to open from the initial pulse to open up the fuel injector. And the other application was I use it extensively in underwater camera work because of the fact I designed underwater cameras for the diving industry. And we would use JB-Weld because it was impervious to salt water, and it would also adhere perfectly well to both not only plexiglass and other materials like that, like plastic materials, but it would also be waterproof, and that was the other application. I've used it extensively for a myriad of different reasons in the process of strain relieving other connectors, using it to embed products within it. I mean, it's a really useful material in a myriad of different ways, and whenever I need something bonded that I can't machine or screw or bolt, that's what I use is JB-Weld.
So what I'm kind of learned from this video, Dave, is that you're going to choose JB-Weld when you can't solder, you can't weld, you can't screw it, and you're just in a situation where there's no other options. Then JB-Weld might be the best option when you're dealing with materials like metal, and where crazy glue or super glue doesn't work.
Well, only because of the temperature range. I mean, this says 550 degrees, this particular 24-hour JB-Weld, and you can't adhere. I mean, on the order of on the cyanoacrylate, starts to melt at about 250 degrees Fahrenheit. So all I can say is that whenever I needed to make a secure bond using JB-Weld, it always worked. And in addition, it encapsulates, meaning it covers it completely and insulates from an incursion of other chemicals and solvents and salt water and air and everything else. So essentially it's a waterproof, watertight, airtight seal. It makes a perfect connection for many times when I need those kind of connections, and there's no other way to do it.
Also when you're using electronics too, when you're talking about conductivity and all that.
Well, yes. I also had sold many programmable power supplies, and they had a programming plug, and that's when I discovered that the 500 volt and higher power supplies, you had to passivate it with cyanoacrylate before you would add the epoxy, because at those voltages it starts to be a conductive material.
Okay, Dave, in our past videos we have tons of comments, tons of questions. Explain to the viewers what's going on with the comments and the questions, because it's an ongoing, it's not just the video, it's an ongoing process. Explain that, how that's been working on our other videos.
Well, I personally answer every single comment with either a thank you or a welcome and all of those things. But more importantly, many people have questions concerning specific applications, and I am glad to be able to very carefully and analyze exactly what they want to accomplish, and then through that process give them the best possible means to do just that. And in addition, I actually include my phone number in every single listing. Every video that we have on YouTube has my personal cell phone number, and I will be glad to answer anybody's question. I'll be glad to talk to them.
I make fun of Dave for talking to people on the phone. He'll talk to anybody, anytime, and spend time with a lot of people. So if you do have questions, I do encourage you to call Dave. It's if nothing else, it'll give you a good laugh.
Anyway, thank you very much,
Thanks,
John.
Thanks,
I really appreciate the accolades.
Thank you, everybody, for watching, and let's keep the discussion going.
If you found this video on JB-Weld epoxy techniques helpful, please click on the subscribe button and you will be notified of our new videos when they arrive on YouTube. As said before, if you wish to purchase any of the products shown in the video, please click on the links in the description area. Feel free to comment on this and our other videos if you want to share or have an additional questions. I promise I will answer every comment. Thank you very much for watching this video and our others.